Okay, we're still in the Math 119 projects, and we're on Project E now. Again, for the students that are looking to submit these projects, you have to submit them as Jupyter notebooks. We've gone through that at the beginning of the course. Hopefully you've paid attention to that and you're able to create a Jupyter notebook if you're so inclined, all right? So I'm going to claim over here is I don't really like using Jupyter notebooks. I like using what's called a terminal application to do these projects over here, all right? So what I want to do is I want to talk about this SAGE project over here, which again is related to the material that's being taught in Math 119. So the first thing I do is I want to launch SAGE. And the way I'm going to do that is I'm going to do that with the command line. I'm going to use terminal. Again, for students looking to do the Jupyter notebooks, you'd have to have a location on your computer where you'd store those Jupyter notebooks. I store it in my user Ron Bannon Documents Jupyter account if I were going to do that. But again, I actually prefer the terminal, right? So I'm going to terminal, and terminal is a command line application, which I'll be honest with you, if you're going into a stimulated career, you really do need to learn how to use a terminal application. All right, launch. It launches it. It's going to launch Sage for me, and I want to get busy with the code over here. And what I notice over here is that when you took math, not when you took, but when you're taking Math 119, or if you've taken 119, you've done system of linear equations. Now this is 3 equations, 3 unknowns. I find it very tedious to do this, even with using matrices and reduced row echelon form, or using Kramer's rule. And I got to be honest with you, as a system gets larger and larger, it really becomes tremendously unmanageable to do the problem. But this is a word problem, and the word problem is over here. You'd read through this. After reading through the word problem in Math 119, you'd have a system like this over here. All right, you'd have a system like this, where X equals the number of bags of seedlings, Y equals the number of bags of the general mix, and Z equals the number of bags of the hardwood mix. Right. So I'm going to go through the code, and I want to point out what the code is all about. And the code is about using inverses to solve a system of linear equations. Right. So I want to go back to my terminal, and what I'm going to do is type this in. And there's many ways to do it, but I'm going to type in reset. I'm going to show you another way to do it as well. But I want to go through this first, reset. And what am I going to do now? Well, I'm going to define a matrix A. You know what? I'm getting a little tired. I'm just going to copy this in. And I'll discuss it with you. I'll put A down. And I want to point out what A is. It's the coefficient matrix with the column. First column is 2, 1, 1. Second column is 1, 2, 1. Third column is 2, 2, 2. And I'm going to type in B. Again, we'll talk about this in a moment. And I'm going to display B for you. And B is a column matrix. What is it? 750, 850, 600. What is that? It's the constants over here. Now remember, if you haven't done it yet, in 119 they certainly solve systems like this. One way to do it is by using inverses. So let me take this down for you. The matrix A, the inverse of A, I'll put caret, inverse, that's a -1. Star matrix B would be the solution to this system over here. All right, we hit return. And what do we get? We get 150. That means X equals 150, and then Y would equal 250, and Z would equal 1,000. I'm going to do this a little differently. And what I'm going to do is I'm going to type the equations as I see them. So I'm going to say equation 1. I'm going to assign it 2 star X plus Y plus 2 star Z. It's an equation, and that equation equals 750. That's equation 1. Whoops, I made a mistake. So someone says, I wonder what your mistake is. I have not defined my variables. I'm going to clear the screen, and I want to define my variables, X, Y, and Z, and their variables. This is important. You're going to make mistakes, and you want to correct them. And you're going to get much better at this. You're going to say, oh yeah, I forgot to do that. And I did. I forgot to do it. X, Y, and Z. And now I'm going to get the equation 1 down again. All right? I'm going to do equation 2 now. No error there. What's equation 2? It's X plus 2 star Y plus 2 star Z. And that is equal to, so use a double equal sign, 850. No error there. Let's put equation 3 down. And what's equation 3? It's X plus Y plus 2 star Z is equal to 600. Hit return. And I'm going to solve the equation now. And this is system, right? So I'm going to solve, and there's 3 equations I have. I have equation 1, EQ1. I have equation 2, EQ2, and I have equation 3, EQ3. The list is put in the square brackets, by the way. This is a list of 3 equations, and I want to solve it for x, y, z. That's a triplet. Again, if I make a mistake or I misunderstand something, it's going to tell me I made a mistake. Let's see what happens. Wow, look at that. X equals 150 as expected, y equals 250 as expected, and z equals 100 as expected. All right? So there's many ways to do this. And I really mean that there are many, many, many ways of doing this. In Math 119, you also learned about reduced row echelon form. Let me go through that with you. A is a matrix. Let me clear the screen first, though. A is a matrix. And what's the matrix going to be? Well, let's write this down. 2, 1, 2, 7, 5, 0. That's row 1. Let's put row 2 down. 1, 2, 2, 8, 5, 0. What's the next row going to be? Let's put it down for you. It's going to be, you know what, I made a mistake already. I got to go back and correct it. I forgot to put a square bracket to sort my matrix out. Let's see, 1, 1, 2, 600. Let me repeat this. If I make a mistake, it's going to let me know I made a mistake. Let's see what happens. Let me display matrix A now. And do I have it? 2, 1, 1, first column. 1, 2, 1, second column. Third column is 2, 2, 2. And the fourth column is 750, 850, 600. Now, this is an augmented matrix. And what I want to do is I want to put it into reduced row echelon form. So A dot reduced row echelon form, RREF. And let's see what happens. And again, if I make a mistake, it'll let me know I made a mistake. And it puts it in reduced row echelon form. What does it say? X equals 150, y equals 250, and z equals 100. So I just did it 3 different ways. All right, this is important that you realize how powerful a machine is. If you're doing this by hand, it's tedious. I don't think anyone enjoys doing these things by hand. It's tedious. Computers can really free you up to do much more interesting problems. Like this is just a 3x3 system, which you do by hand in Math 119. If this were like 20x20 system, I'll be honest with you, it would be terribly difficult to do by hand, but Sage would have no trouble whatsoever doing it. Now, whether it's doing it by inverses or reduced to echelon form or actually solving a system of linear equations, it's going to do a really nice job, and it does it very quickly, by the way. Thank you for paying attention.